Okay, chapter 1, section 3 is transformations of graphs or of functions. One vocab word that I want you guys to know is a parameter, and that is one of the constants in a function or equation that may be changed. An example would be f of x plus k. K is your parameter. It's a constant, it's a number. So, looking at this first example, we have this graph here in black is f of x. So we plugged in these points, -1, 1, 3, 5, to get these outputs of -2, 2, -2, 2. So -1, -2, 1, 2, 3, -2, 5, 2. Those are just your ordered pairs. I want to change this graph. I want to transform it. I want to say, I want to see what f of x plus 4 would give me. So I'm going to plug in my x value still. And I'm going to look at my f of x value. So I have, when I'm at -1, my f of x is -2. So from f of x, I want to add 4 to that. So -2 plus 4 is going to give me 2. 2 plus 4 is going to give me 6. -2 plus 4 is again going to give me 2. And 2 plus 4 is again going to give me 6. So I now want to graph these x values, -1, 1, 3, and 5, with these y values, 2, 6, 2, and 6. So when I'm at -1, 3, 4, 6. When I'm at -1, my y value is 2. When I'm at 1, I'm at 6. When I'm at 3, I'm at 2. And when I'm at 5, I'm back at 6. So then this is my new function transformed. So what happened with this graph? Well, from -2 to 2, I moved up 4. So from this spot to this spot, there's a distance of 4. So I went and I picked up this whole graph and I slid it up 4 spots. For that, we can kind of write a conjecture or like a proof stating what happened. So I went ahead and wrote them out. For g of x equals f of x plus k, if k is greater than 0, so in this case k was 4, the graph is translated, it's slid. When it's translated, it means to slide up k units. So it went up 4 units. If k is less than 0, then the graph is translated down k units. So if that was -4, it would have slid down 4 units. Okay. For this next one, we have g of x equals f of x minus h. So this time, my parameter is on the inside of the parentheses. Up here, at the first example, it was on the outside. Down here, it's on the inside. And we're going to say h equals 2. So you will see that I have x and f of x, which is my original points that we used up here. And here's my original graph. So this is my parent graph. So when I go to plug in these points, my original points are going to change with this. So this is happening to the function. So technically, if I was at -1 and I plugged in 1 and I subtracted 2, 1 minus 2 gives me -1. 3 minus 2 gives me 1. So what number minus 2 is going to give me 3? That's going to be 5. And then what number minus 2 is going to give me 5? That's going to be 7. So this time the change is happening here in this column. So here's my original. These are the points that I want to graph. at 1, I'm at -2. When I'm at 3, I'm at 2. When I'm at 3, I'm going to be at 2. When I'm at 5, I'm going to be at -2. And when I'm at 7, I'm going to be back here at 2. So I took what's in red, and then I'm just going to connect my dots there. And this time you can see that your graph moved over to the right. So H was positive, and I moved to the right. I picked up the whole graph, and I slid it to the right. And that occurs when your parameter is in with your function. So this conjecture would say, for g of x equals f of x minus h, if h is less than 0, the graph is translated to the left, the absolute value of h. So if h was -2, in here, we would have x plus 2, and we would be sliding it to the left. For g of x equals f of x minus h, if h is greater than 0, so this time, just like that, the graph is translated to the right. So if it happens to the function, it's going to be a translation along your x-axis. If it happens outside the function, it's a translation along the y-axis. You'll see we have the same parent function again, same points. This time we're going to use a, and a is always going to be in front of your function. It's going to be multiplied by. So a is going to equal 2. So I'm plugging 2 in for a. So -2 times 2 is -4. 2 times 2 is 4. -2, when I'm at 3, I'm going to be at -4 again. And when I'm at 5, and if f of x was 2, 2 times 2 is 4. So then when I'm at -1, I'm at -4 in my y. So -1, -4. When I'm at 1, I'm at 4 in my y-axis. When I'm at 3, I'm back down here at -4. And when I'm at 5, I'm back up here at +4. So then my graph, my new graph, is going to look like this. This is my parent graph in black. In red is my new graph. And you can see that it's kind of stretched out vertically. Goes up by a factor of 2. So if a is greater than 1, the graph is stretched vertically away from the x-axis. So we stretched it up and down away from that x-axis by a factor of a. So in this time it went up by 2, by a factor of 2. If 0 is less than a, which is less than 1, so if a is between 0 and 1, the graph is compressed, so it's going to shrink. So if a is greater than 2, it's going to stretch. If a is less than 1 and greater than 0, so if it's between 0 and 1, then it's going to shrink. It's going to be real close to that x-axis by the factor of a. This last example is what if we have a fraction in here? So 1 over b, and this is happening inside the function, just like on the previous one, it happened inside the function. We added or subtracted. So this is going to affect us on the y-axis. We're saying that b equals 2. So we have that fraction. So if I put in -2 and I multiplied it by 1/2, because b is 2, so I have 1/2 times -2, because that's my input for g. My actual input for f is -1. Because 1/2 times -2 is -1. 1/2, positive 1/2 times 2 is 1. So in order to find what number I have to plug in here, I'm going to multiply this number by 2. So 3 times 2 is going to give me 6. And 5 times 2 is going to give me 10. So this way, when we work backwards, we take -2 times 1/2 to get -1. 2 times 1/2 to get 1. 6 times 1/2 to get 3. 10 times 1/2 to get 5. Okay, and again, these are going to be my output values. So, on my graph, here again is my parent function. When I'm at -2 for the x, I'm at -2 for my y. When I'm at 2 for my x, I'm at 2 for my y. When I'm at 6, 3, 4, 5, 6, I'm at -2. And when I'm at 10, I'm back up at +2. So you can see here, my graph is pretty stretched out compared to my parent graph. So if b is greater than 1, which it was, it stretched horizontally away from the y-axis. So we're stretching it away. We're stretching it down the x-axis further. But if b is between 0 and 1, it's going to shrink towards that y-axis. It's going to become real small, so it's going to be real tiny. That is translating functions. So remember, if it happens 2 inside the function. If it happens inside the function, it is dealing with your x-axis. If it happens outside the function, it is dealing with your y-axis. So inside, you're going to move along the x. Outside, you're going to move along the y. Your homework for this section is page 31, 32, numbers 2 through 8 even.